Let's review exponents. So if n is a positive whole number, then a number a raised to the n power is just abbreviation for multiplying a to itself n times. You could also have a raised to a fraction power like 1 over n. And what this means is if you have a to the 1 over n power equaling b, this means that a is really equal to b to the n power. Sometimes this relation is also denoted with a square root type symbol with a little n up here. So that's alternative notation for this expression. Let's see some examples. So 5 to the 4th power is simply 5 multiplied by itself 4 times. That's all there is to it. If I have 16 to the 1/4 power, let's say that's equal to b. This means that 16 should equal b to the 4th. So I'm using this relationship here with a equals 16 and n equals 4. So I can write down what this is, and by maybe trial and error, we could see that b is equal to 2 because 2 to the 4th power is 2 times 2 times 2 times 2. That is 16. So 16 to the 1/4 power is 2. Let me do another example, one that I see students get confused on a little bit. What if I have the square root, and when I have the square root symbol, that's the same as if I put a 2 where the n is. It's raising up a number to the 1/2 power. That's what this square root symbol means. So if I have the square root of -6 squared, a common mistake that some people make when looking at this is they think the answer is -6 because the square root and the square cancel. That's not completely true. So let's see what this is really. So this is the square root of 36, because -6 squared is -6 times -6. The two negatives cancel. You get the square root of positive 36. And this is positive 6. So in general, it's probably a good thing to realize that the square root of any number squared, the square root of a squared is not equal to a. Instead, it's equal to the absolute value of a. Because if you happen to have a negative in there and you square it, the negative goes away. And there's no negative anymore. So that's what this absolute value symbol does. It takes any negative sign and makes it positive. So let's write down some basic properties of exponents. So property 1 is if I have a to the n power times a to the m power, I add the exponents, a to the n plus m power. This is because if I'm multiplying a n times and then a m times, the total number of multiplications is therefore n plus m. If you have a negative exponent like a to the negative n power, then that's what we use to denote division. So a to the negative n power is the same thing as 1 over a to the positive n power. Property 3 is that if I have a times b to the n power, then this is a to the n times b to the n. And the last property I'd like to write down is a to the n to the m power. This would be the multiplication a n m. So these are all true properties, but I'd also like to write down some embarrassing mistakes. Some embarrassing mistakes that I never want you to make. So here are mistakes. Please don't make these mistakes. I'll get irritated. but some people will, because I see them all over the place. If I have a plus b to the n power, then that is not equal to a to the n plus b to the n power. If you ever are unsure if something's true in mathematics, simply plug in certain values and see if it works. So plug in a and b equals 1 and n equals 2. So if a and b are 1 and n is 2, then I have 2 squared. This side would be 4. On the other hand, if a and b are 1, then this would be 1 plus 1. So the equation is false if you plug in any interesting values for a and b. Another mistake I don't want anyone to ever make is the square root of a squared plus b squared. Well, that's certainly not equal to a plus b. And again, maybe if you're ever confused if something's true or not true, my rock solid advice is just plug in certain numbers and see if it works for your choice of numbers. So if I plug in a equals 1 and b equals 1, about the simplest numbers I can think of, then I get the square root of 1 plus 1, or the square root of 2. And then if I plug in a and b equals 1, I get 2. So you could see that mistakes are actually mistakes by actually plugging in values. Okay, let's end this video with a couple of examples in simplifying exponents. So let's simplify negative xy to the third power divided by x squared y. So going back to what it means to raise something to a power, this third power means I multiply negative xy with itself 3 times. Then I'm going to divide by x squared y. Well, I have 2 x's on the bottom, and I can cancel out 2 x's on the top. I have a single y on the bottom. I can cancel a single y on the top. I have 3 negative signs. So negative 1 times negative 1 times negative 1 is still a negative 1. So I have negative 1 times, I have 1x and 2 y's left over. So negative 1 xy squared. Let's do another one. How about if I simplify? How about let's do 27y to the 6th power to the negative 2/3 power. Okay, so looking at property 3, I can say this is 27 to the negative 2/3 power times y to the 6th to the 2/3 power, negative 2/3 power. Now, 27 is equal to 3 cubed. So 27 is 3 times 3 times 3. So I have that. Then I'm going to say that this is 3 cubed to the 1/3 power, all raised to the negative 2. I guess I'm using property 4 here, because I'm taking this negative 2/3 and I'm writing it as 1/3 times negative 2. The reason I'm doing that is because now I have a 3 to the 3rd power times to the 1/3 power. So those will cancel each other out. I still have this y to the 6th And I'm going to do the same thing. 1/3 all raised to the negative 2. That's a lot of parentheses. I don't really like this, but okay, we're simplifying. This will be just a 3. So I have 3 to the negative 2 power. This y to the 6th to the 1/3 power, I will use this property again. N is equal to 6, m is equal to 1/3. That will give me y squared to the negative 2 power. And then to finish things up here, I believe I will get something to a negative exponent. That means division. 3 to the negative 2, or that's actually going to be giving me a 1/9, and then I have y to the 4th. So you can use these properties of exponents. I'm going to ask you to do them in the exercises to simplify expressions. Okay, wonderful.